Okay, magandang gabi. Audio check muna ako. Kamusta yung audio ko? Hindi, send reactions. Okay, sige. Thank you. So let's begin. So last time we talked about an introduction to networks. Okay, so we are still in chapter 1. Okay, what we expect to finish this evening is I think chapter 1 or 2 and a little bit on chapter 3. Okay, so let's continue. Okay, so last time, as I said, we introduced networks. I think we talk about some of the last part would be elements. What are the networking elements, okay, of the networks, okay? So commonly in a networking site, ito yung makikita nyo, mostly sa different type of networks, ang makikita natin dito is the end devices. Hold on. Okay. So we have the end devices and the intermediary devices. Okay. So these are the end devices, the PC, laptops, notebooks. Okay. If you do have cell phones or end devices. We have switches, routers, bridge, or intermediary devices. Okay. So if you're going to build networks, just what we introduce in laboratories, you need to have a device first. So right now, ang tawag ngayon dyan is appliances. So you need to have an appliances to build a simple networks up to a complex network or create an infrastructures of networks. Okay. So to be able to connect yung mga yan, so let's say for example, you have switch and you do have another switch. Okay. To be able to connect this one, so kailangan ka may mga connection. So it's either you use a wired connections using a UTP cable, okay, or a connection via a fiber optics using a fiber, and via a coaxial cable, which this is what it looks like, similar to what you use in the antenna of your television. If you wanted to uh, receive a high resolutions, you use outside antenna. So it's a coaxial cable and the wireless. So before, in the earliest technology of networks, we make use of the coaxial cable to create a simple network like a bus topology. Okay. And nowadays, very dominant na ngayon ang wireless, and this one is a wire but using a fiber LAN networks. Okay. So let's talk about network design. So as we go along, I think in a final period, we will talk about mostly on the network design using standards. Okay, so ano yung mga standards natin when we create a network, such as the distance between one PC to another, okay, and so on and so forth. Okay, but theoretically, a network design involves a planning and okay, planning and creations of a computer networks. So most likely you need to have a specific requirements to do that. Okay, so ano na bang objective mo, okay, to create that particular designs. Okay, so a network design is as simply as you connect nodes via links. Okay, so common yan, sabi ko nga. So if you do have a routers, okay, and you do have a routers, so you can connect this via a gigabit ethernet. Okay, so this is a node wherein you can exchange information from your router. So if you do have a switch here, and if you do have a switch, so the switch is connected through a PC, and this one is connected also to a PC. So to be able to exchange communication here, so kailangan natin ng connections. Okay? So timely, you need to have an exchange of information in a reliable format, efficiently, safely, and privately. Okay, with a minimal cost. Okay. Now, when you wanted to connect all the networks, okay, so marami siyang requirements analysis, okay, to be able to create a simple to complex networks. Okay. So, ang una mong kailangan malaman dyan is, ano ba yung requirements ng stakeholders? Anong connection ang gusto niya? Gusto niya ba wired connectivity, wireless connectivity, or mix, okay, or radio frequency or RF? So saan niya gagamitin yung networks, okay? May server side ba yan, okay? What particular topology ang gagamitin niya, okay? Yung mga topology is like, for example, the star topology, you do have the bus topology, you have a hybrid technology wherein a clustered type, okay, of topology on how the devices are being connected through the networks, okay? Next is the type of networks architecture. So this is the type of network architecture. So meron tayong several types na pwede nyo gamitin. One is directly connected networks. The other one is circuit switch and the packet switch. So you need to select appropriate network architectures. Okay. The thing with this is you can create a peer-to-peer networks. So let's say, for example, point-to-point, pwede nga, dalawang PC, you'll be able to connect that. Okay? You could connect via a client and a server. So meaning, you do have a server here, then you have a client. Okay? Client connected via a router and connected yung client mo. Okay? Or you can connect a simple point-to-point communications directly. Okay? So, another thing that you need to consider in network design is the hardware na gagamitin mo. The hardware infrastructures. So, the type of networks, the type of routers, the type of firewalls na nakita nyo. So, there are hundreds and thousands of models out there, brands, proprietary brands that you'll be able to maximize in use. Okay? So, lahat ng mga yan, depende yan sa price. Okay? So, big sabihin, some are costly, some are cheap. Okay? But, siyempre, kung mas mura yan, you will compromise the performance. Okay? So, another is the connectivity issues. Okay? So, the connectivity issue is in form of the following. So, let's say you wanted to connect your networks via a cable, okay, an internet cables, katulad kanina nakita nyo, you have the fiber optics through a fiber LAN, and so on and so forth, okay? So, in this time, you'll be able to decide which of which ang mostly applicable to your design, okay? So, what drives a networks? So, there are several factors that a network design and a specific requirements can vary based on the organizations. So, yung mga organizations natin or infrastructures depending on what particular goals, kung gaano kalaki yung size ng company. Oh, so you employed hundreds to thousands of employees. Anong network infrastructure deliver ng ganung kadami users? Let's say, call center. Okay, yan yung mas madami PC. May data centers, may pinangangalagaang systems, and so on and so forth. Okay, what particular industry you belong? So, manufacturing side, eskwelahan ba yan? Okay, kung mapapansin mo in a school environment, if masyadong malaki yung eskwelahan, dapat malaki yung network infrastructures yan. Kasi, siyempre, ayaw naman ng bata na mabagal yung internet niya. Okay, some other schools around the globe, mayroon silang mga dormitories. So you cater also the internet in the dorm. Okay? So habang lumalaki yung industries, lumalaki yung demand natin when it comes to use of the internet and basically the bandwidth. Okay? So what are the key drivers here? Okay? So the key driver here is siyempre the business requirements. Okay? the performance of the networks. Okay, so it includes the data transfer speed, kung gaano kabilis. Yung latency will be talk about in chapter 3. How reliable is your networks? How reliable is your internets? Okay, baka naman intermittent yan. Now it works, now it doesn't. Na kumilog lang, kumidlat lang, wala nang internet. So most common scenario yan sa atin eh. Kasi some of the networks sa Pilipinas ay suspended. Okay, so mapansin nyo sa subdivision nyo or dito sa Dasmariñas, kung mapansin mo yung mga cables natin ay nasa taas, hindi siya underground. But in the network infrastructures nowadays, kung mapapansin nyo, from ISP down to cities, naka-underground na yan. Okay. Some of the telco uses underground cabling. Nagkakaroon lang siya ng, so underground cabling is, let's say for example, you have an ISP here. So yung ISP mo, nasa ilalim na yung kable niyan. Pagdating sa mga city, may converter lang tayo. So fiber optics to fiber optics. So suspended na yan sa mga poste. So pag nasa subdivision ka, nakataas yung mga cable natin. But there is a limitation to that. Depende sa design. So ganyan yung most common cases. Kaya kapag umulan, nawawalan tayo ng internet. Okay, very crucial yung design. Okay, so another concerns natin dyan would be the security when it comes to network design is the security. So how will be able to protect against unauthorized access? Okay, so how do we protect the networks in terms of the data breaches? Okay, most common yung mga phishing natin ng website and the cyber attacks sa mga kumpanya to be able to gain access to the infrastructure. Users, okay, on how they basically use the networks. Okay, lag pa ako, hold on lang. Wala nang tao sa iya. Okay, kamusta audio ko? Okay, sige, thank you. Okay, when it comes to other things, okay, dito papasok yung type of applications that you'll be able to use. Okay, so are you on to video streaming? So papasok din yung requirements mo ng bandwidth. So let's say ang networks mo ay dominante yung nag-stream. Okay, so dapat mataas yung bandwidth allocations mo dyan. So you use the VoIP or yung tinatawag nating voice over internet protocols. The voice over internet protocols, yan yung mostly ginagamit ng mga call centers, okay, to call you or to call them, okay, via VoIP. So hindi na siya gumagamit ng circuit switch type of networks. So another is the file sharing. If you are more on to a FTP, okay, you do have a FTP server, you have a file server, you're getting a data or information onto the servers na medyo malaki, a gigabit of information. So let's say for example, nasa isang networks ka, sa television, sa movie outfit, medyo malalaki yung requirements natin dyan when it comes to video. So yung mga videos na yan, hindi siya accessible via a standalone or on-site. So yung mga data niyan is online, okay, that could be accessed through cloud. So kailangan natin ng mas mataas na requirements yan. Next is who deploys the networks. Okay, so papasok yung enterprise. This is more on enterprise private. This is a government type and we do have the end users. So each of this depending on a specific requirements. Okay? So, medyo mataas if we're going to deploy our networks into an enterprise. Okay? Pag sinabing enterprise, medyo malaki yan. It consists of different branches. It consists of different departments. So each department requires you to set policies, protocols, programs, and so on and so forth. Okay? So what about on the government side? Ito naman si government side, it has a specific requirements. Okay? Most common would be, ang na-encounter ko dyan is they are not more on cloud. Okay? So hindi pa sila medyo, hindi naman natin masabing hindi pa ganun ka positive yung uh, uh, reactions nila in integrations of the cloud ng mga services, especially services, websites, applications ng mga government offices natin in the Philippine City. Okay? So, ang kinakatakot to nila, madali daw ma-hack and stuff like that. So consider that. And the end user, yung mga end users are pretty much the same with if you are a subscriber of the an ISP. Okay, you are considered as an end user or an end user which with respect to an enterprise setting. So let's say for example, client ka lang, okay, let's say kahera ka lang, isang manager, so you're considered an end user in the network. So maraming consideration dyan if you're using a laptop, if you're using a desktop, and if you're using a mobile devices. Okay? So where is the network deployed? Okay, so ang networks natin could be deployed in a home. Okay, so the architecture are simple as you are connected via an ISP through a ADSL connection, so asynchronous digital subscriber line. And then fiber to fiber yan and fiber to LAN. Pagdating sa'yo is fiber to LAN. So that's the basic operations. Okay, and you do have the building. So one building is connected through a building. So most likely you're using a fiber optics connectivity, or most likely you are using a radio, okay, or RF. So you do have an antenna at one building. So ito yung building mo. Okay, ito yung building mo. Tapos may antenna tayo dyan. Okay. So common practice nito, one example nito is yung dormitory sa Lasal. Okay, when I was a network administrator dyan sa dorm nila. Okay, ang connectivity namin dyan is RF. So this is an ISP and this is the building, yung dorm ng mga nag-med students. Okay, so directo yan kasi ayaw nila magbutas dyan sa Lasal, dyan sa HSI. Okay, sa tapat natin halos. Ayaw nila magbutas yan doon. So naka-radio kami dyan. So, from ISP to the radio. Okay, so as we go along, we discuss the architecture. So ganyan yung deployment yan. So pwede yan. Okay. Let's say you have a campus. Sa EAC, ang architectures nito ay meron tayong Manila. So this is Cavite. Okay. So lease line to. Okay. So a lease line using fiber. Okay. So connected yung EAC Manila directly. Okay. Using a fiber networks. Okay. So you can connect a state or a country via a submarine cable or via a satellite. Okay. So yung mga continent and globe is via satellite kasi medyo malayo na yan. Or it is connected via a submarine cable per country. Okay. So how do we evaluate a network in general perspective na discussion? So we evaluate the networks based on the matrix. Okay. So think of again of a transportation network sa last meeting natin. So how many cars it service? Okay. So how many cars can it service? So habang lumalaki, habang dumadami yung sasakyan, mas madaming tumatakbong sasakyan sa kalye, mas marami kang masasakyan. Okay? So how fast can it serve them? Okay? So, yung point A to point B. Yan. So, kung mas marami kang sasakyan na nari mo to, uso-uso na yung angkas, mga ganun. Okay? So, ah kapag ah, avail ka ng services ni Angkas, okay, ipo-point mo yung destination mo from your source and the destinations, okay? So, from A to B. So, how fast can it service them? So, there are certain delays kung malayo yung magsa-service, okay? Or madaming siniservice one, okay, and so on. How reliable can service? Okay, so collision, losses, outage, and probability that uh, 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 hindi siya magda-down. Okay, so let's say for example, yung application, kung hindi siya mag-offline, okay, hindi mapuputol-putol yung connections mo because of the network problems, okay, and so on. Okay, can it provide any guarantees? Okay, so yung data mo ba na sinesend or video na sinesend mo from point A to point B will be delivered as 100% of using a QS. QS stands for quality of service. Okay, quality of service yan, nagbabari yan if you are transmitting via audio, via video, or via text. And other metrics for that matters. Okay? So you need to monitor the network traffic. Okay? So in examining the networks, dun sa activity niyo sa laboratory, kung mapapansin niyo, may activity din ng visual routes. Okay, so nakita niyo kung paano mag-send ng hops per hops yung router to router. Okay, papunta sa iyo. So ilang router ang pinagdadaanan mo, okay, para makarating sa iyo yung website ni Facebook. Okay? Kung ternex mo si Facebook na website www.facebook, converted yan into an IP, papakita niya sa inyo yung pinagdaanan niya ng mga number of hops and number of routers. Okay? So diyan papasok yung network traffic. So when it comes to evaluations of network in terms of the number of users, yan, devices and applications. So nagbabari yan. Okay? So you need to conduct a regular evaluations of the networks to prioritize which type of traffic are based on the quality of services natin policy. So, yung mga policy niyan, yan yung ginagawa mo dun sa configuration ng networks mo. Okay? So, ang mga common yan is, kung sabi ko nga, if you are demanding a high priority base for video, so dapat top priority or bibigyan mo na mas malaking bandwidth si video rather than the other services that it offers like audio and the text. Okay? So, another is, let's say, you evaluate in terms of the networks. Okay. So, yung ability niya to check if mas maganda ba yung gamitin tong network na wireless or wire. Okay? Gaano kalaki yung coverage kapag gumamit ka ng wired versus wireless. Okay? Most common naging problem ko yan. Okay? So, in other designs, let's say for example, ito, sa isang ganito, isang floor na yan, meron kang 20 rooms yan. Yan. Okay, so anong mas maganda dito? Kasi mas preferred ng mga tao is wireless na sila. Okay. So, let's say meron ka ditong mga 15 floors. Okay. So ang daming users mo. So yung signal strength mo, mag-i-interfere yan. Kasi, based on experience ko to nung network admin ako dyan. So itong mga to, binablock niya yung signal kasi CHB. So it's a concrete hollow block. So binablock niya yung signal ng wireless. So most likely kung ang access point mo ay nasa labas. Okay? Pagpasok pa lang nito, sarado yung pintuan ng mga door. Ang mangyayari diyan, very low yung nare-receive mong signals. Okay? So, magreklamo yung mga yan. So, na-encounter namin yan during the setup of that particular networks. Okay? So, there are a lot of to be considered on how you'll be evaluate the networks. But most likely, ang titingnan natin dito is the speed. Okay? The delay, the latency, and the system throughput. From point A to point B, gaano katagal yan mag-transfer. Okay? Now, in a network environment, in the network design, there are different networks na pwede natin gamitin. Okay? One of which is the point-to-point, and the other one is a multiple access. Okay? So directly connected networks is basically a set of networks that are connected to each other without intervening other networking devices. So para magawa natin yung directly connected, we make use of different devices such as routers and switches. Okay? So what are the things that we need to consider if we do have a directly connected devices? Okay. So one is the physical connectivity. Okay. So physical connectivity is something that devices are directly connected, physically linked through a cable. Okay. So wired siya or a wireless connections. Okay. So maraming parameters na pwede nating i-consider dyan kung ano yung type ng topology niya. Okay. So this one is a multiple access or all nodes are shared on the same physical medium. Okay? So dito, papasok yung a point-to-point connection. So you have a PC and you do have a PC connected. Okay? Ito yung nangyayari sa kapag nagda-download kayo. Okay? Ng mga movies nyo. Okay? So it's either isa lang yung seeder directly connected ka sa PC na yun. Kung naka-multiple seed yun, so you have a multiple access. Ito yan. Okay? So in this point-to-point communication, it's a simple daisy chain arrangement. Okay? So your device is connected to another device. Okay? So mas bilis siya. It's very simple to operate, not too complex. Okay? Which is directly connected siya. Okay? So a switch network can be in form of a circuit switch and a packet switch. What is the difference between the two? Okay? So yung networks natin are connected through a what we call switches. Okay? So for your information, switch is basically a intelligent device than hub. Okay? But the most intelligent device is basically a router. So before the evolution, ito yung mga ginagamit natin. Okay? Kasi mahal ang router before. Okay? So hub muna tayo and then switch. Okay? So switches are intelligent device na pwede nating i-operate under the layer 2 protocol. Under layer 2 protocol of the open system interconnection. Etong router, this is layer 2. This one is layer 3. Nowadays, sa mga bagong technology, meron tayong switch na layer 3 na. Okay? So unlike yung hubs natin, hindi siya nagbo-broadcast sa all devices natin. So yung switches, yung data natin can broadcast it to other devices connected to it. So it basically creates more intelligent connections, more secure connections rather than using a not too good hub. Kaya medyo hindi na natin ginagamit to. Ito na yung ginagamit natin. Sa architectures natin is we'll be able to use switch and the routers and dalawang yan. Okay? So, ano ba yung switches? Again, okay? So sa switches, okay, ang switch network is basically a point-to-point. Okay? Okay, this is a point-to-point. P to P or P to P. A point-to-point communications. So each device is directly connected to the switch port. So let's say for example, ito bridge to. Okay, so you have a switch, and switch. So the PC is directly connected to the switch and that is point-to-point. So It basically enabled a dedicated communication from or between devices. Okay? And that is your PC and your uh, device. Okay? So, what is a circuit switch? Okay? So, ang circuit switch is a type of networks na provide higher uh, 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 bandwidth compared to the shared networks. So, each of the networks can have a full bandwidth, okay, onto the switchboard. Okay? So, ang common technology na ginagamit is basically a plain old telephone system or what we call PO, plain old telephone system or POTS. Okay? So, kung mapapansin nyo, kung nanonood kayo ng mga pelikula, di ba, pag tumawag ka, nare, itong Pilipinas, Philippines, ito ay US. So, hindi ka pwedeng direct na tumawag dito. May connecting pa yan. So, dito sa Pilipinas, dapat may open port para makapag-connect ka ng direct dialing papuntang US. Okay? So, kailangan mo nang may open na port or switch. Okay? Para ma-receive niya yung tawag mo. Kaya may operator kang pupuntahan mo na. Sabi mo, can I have direct, international direct dialing sa US? So, titingnan niya ngayon sa switch niya kung may available para i-connect ka doon para marinig mo yung kausap mo sa other line. Kasi circuit switch siya. It's basically a dedicated circuit. Okay? Para magkaroon tayo ng link between two connections. Okay? So, eto mga to, medyo costly yan kasi medyo mahal yung bayad per minute yan. Okay? Kung kapansin nyo katulad sa telepono nyo sa bahay, yung telepono nyo sa bahay is a circuit switch connections. Okay? Ang technology. Okay? Kapag packet switch, ayun yung ginagamit internet. Kaya, kung mapapansin nyo, hindi na kayo naglo-load ng cellphones nyo ng tawag kasi kung ang ginagamit nyo na is Facebook, yung mga soft phones na. Okay, ano yung mga soft phones natin? Katulad ng application like Skype, katulad ng Messenger, may voice na yan, and other soft phones out there, katulad ng WhatsApp, Line, and so on and so forth. So pag tinawagan mo yung kabilang linya mo, wala ka nang babayaran na per minute. Kahit 24 hours kayo mag-usap, as long as you do have the internet, connected kayo. So yun yung ginagamit natin, a packet switch. So si packet switch, ang ginagawa niya, the data is basically split into blocks. So yung dumadaloy sa communication mo is basically a packets. Okay? So, dumadaloy siya sa internet connections natin. Okay? Very straightforward ang communication. It basically store and forward strategy. Okay? So, bigyan natin ng mas malalim na discussion and in-depth discussions of a circuit switch networks. So, a circuit switch is a type of telecommunication in which, sabi ko nga, you have a dedicated line. You do have a dedicated path or a circuits na kailangan mo ma-establish between two connections. So in contrast with other communication like yung packet switch na hinahati-hati natin yung packets. And then yung packets na yan will be traveling to different routes. And then yung different routes niyan will end up to the last route niya, which is i-assemble niya yung packets, and then naturally real time niya maririnig mo at marireceive mo yung data mo in an instant. Okay? So in a circuit communication, once is complete, the connection is ended and links are basically released. Okay? This is the common scenario. Okay? So it's a continuous connections, okay, until yung conversation mo is terminated. So para ma-ensure natin yon, we need to have a specific communications. Okay, it could be in form of an analog communication, which is the traditional form. Okay, which is the voice. Voice is a traditional type of analog transmission. So the analog signal is basically modulated and transmitted over a dedicated lines. Ito yung most common na ginagawa natin kapag gumagamit tayo ng telepono. Okay? A circuit switch consists of a fixed bandwidth. Okay? So, ang technology niya ay associated talaga sa telephone system or PSTN. Okay? O yung tinatawag nating plain public switch telephone networks or PSTN. Okay? So ang tanong, reliable ba ang paggamit ng circuit switch? Okay. Kung mapapansin nyo, nagda-drop tip. May mga calls tayo, kapag tumatawag ka sa telephone, nagda-drop yung call. Nagkakaroon ng hiss sound, nagkakaroon ng party line. Kasi susceptible siya sa noise. Okay? And this is not very efficient. Kung ito yung gagamitin natin for data transmissions, hindi siya efficient. Okay? Kaya, mas mataas yung nangyayaring delay ng communication. So, pag tumatawag ka tapos napakaraming gumagamit, medyo may delay yung audio mo, okay? Dun sa receiving recipient. So, unfortunately, ito ay medyo nawawala na for this era. Okay, kasi nasa packet switch na tayo pumapasok. Including the telephone system sa mga susunod na panahon. Ang predictions nga dyan nila, dapat free pati internet. Okay, so kailan kaya mangyayari na pati internet natin ay free. Pero ngayon, so mapapansin nyo, pamura na ang mga networks natin ngayon, especially the ISPs. Okay? So, anong advantages if you're using the circuit switch? Okay, so despite na pinapalitan na siya ng packet switching nowadays in this particular modern technology, there are several factors pa rin kung bakit natin siya ginagamit sa voice communications. Okay? In the circuit switch, the quality of service is predictable via bit rate and delay. Okay? So, anong ibig sabihin yan? So, dedicated kasi yung circuit switch. Kapag dedicated siya, basically low latency siya. Okay? So, if it is a low latency, during conversation, yung low delay kasi natin is very crucial when it comes to real-time communication. Okay? Especially sa voice calls. Okay? Next is, yung packet loss natin is rare. Okay? Very little. Pero nagda-drop pa din yan. Okay? Simple routing. When it comes to multiplexing, when it comes to network management, when using the circuit switch is very advantageous. Okay? So, the bandwidth for the entire circuit is basically reserved for a specific duration of the conversation. So, ginaguarantee niya yun that you do have a specific amount of bandwidth para mag-engage yung communication nyo at the sender and the receiver. Okay? So, magiging consistent na ngayon yung conversation nyo. Dire-diretso pa rin naman yan. Di ba? Pag telepono, pag inangat mo yung telepono mo, dire-diretso yung conversation. Sometimes, nagda-drop, pero dire-diretso pa rin yan. Unlike otherwise, i-terminate mo siya. What do you mean by terminate? Ibaba mo yung auditibo, it basically ends the communications. Okay? So, magandang gamitin talaga siya sa voice. Because it has a continuous dedicated circuits. Okay? So yung voice natin are transmitted without significant delay. Or yung significant delay dyan in network terminology or datacom, yung jitter. Okay? Kapag nag-jitter yung voice mo, yung boses mo ay para siyang katulad kanina, yung medyo putol-putol yung connections ko, ay hindi siya reliable at clear yung naririnig nyo at your end. Okay? So, in terms of low per packet overhead, so yung forwarding niya is based on time slot of the frequency. So, it has a dedicated circuits communication. So, meron siyang may start at end. Okay? Yung communication siya. Okay? But sabi nga natin, inefficient siya for data communications. Okay. So, dito papasok yung disadvantages niya. Okay. While the circuit switch has different advantages kung bakit until now, ginagamit pa rin natin sa plain old telephone systems. So, there are different disadvantages compare mo to modern technology, which is the packet switch. Okay? So, first one would be very limited yung scalability natin. Hindi na siya easily scalable. Okay? So, when you add more users, when you add more devices, very challenging na yan for dedicated switch. Kasi, di ba sabi ko nga sa inyo, kailangan may dedicated connections ka para magamit mo yung international dialing mo. Okay? Kailangan may sarili kang pinagdadaanan ng communications. Unlike yung nowadays, sa isang communication, pwede na tayong dumaan ng maraming packets in one line. Okay? So, very limited siya in that case. Next is medyo mahal, di ba? Pag gumamit ka ng telepono versus sa internet, okay, kung may parents kayo around the globe, pag tinawagan mo siya using your telephone, dollar yun. Okay? USD ang per minute ang usapan doon. Unlike that, kung may internet siya, kahit nasa ang parte ka, mag-video call lang kayo, makikita mo pa itsura niya. Okay? So, that's basically the limitation. Medyo mahal siya compare mo kay packet switch. Okay? So, the circuit switch remains used for only voice communication, a traditional type. Okay? And basically, it becomes obsolete nowadays. Okay? So, let's talk about the packet switch naman. Okay? So, ano naman ang packet switch into the networks? Okay? So, in computer networks, the data are being divided into different packets. Okay? So, data is divided into packets or messages. And then, these packets are basically transmitted over the networks. Yung kabaligtaran ni circuit switch, meron siyang dedicated communication path para magkaroon kayo ng conversation. Ito, ang isa-send niya is basically a discrete packets. Okay? Which is 1 and 0. Okay? Yung 1 and 0 na yan, tatakbo yan sa different daan or routes para ma-reach yung destination. Pagdating niya sa destination, i-assemble niya ulit yung communications natin. Okay? So, yung nangyayari sa atin, kapag nag-i-internet tayo, pag gumagamit tayo ng applications like video and text, we are now using the packet switch communications. Okay? So, as I said, this packet are broken into a smaller packets for transmission. So, sa loob niyan, maraming parts siya as we go along sa OSI. Meron siyang data. Yung data kanari, voice or text lang. So, may header file siya. Yan yung routing information niya. And meron siyang trailer. Yung trailer, ginagamit natin siya for error checking. Okay? So, yung packets natin is basically routed into different networks based on the destination address. So, matalino siya kasi isi-send niya yung packets hindi sa lahat ng networks. Hindi niya ibubrot kasi yan sa lahat. O itatanong ka niya, sa'yo ba tong packets na to? Sasabihin ng isang computer, ay hindi. Sa'yo ba to? So, yung mapapansin mo, lahat dadaanan niya. Si packet switch, alam niya kung sino ang sisendan mo kasi meron siyang destination address doon sa header niya. So, yung each packet now are take different paths. Okay? Pag dumaan siya sa different paths, it basically allows you to have a greater reliability when it comes to communication of your networks. Kasi nagbabago-bago yan. Okay? So, the packet switch in networking technology is a connectionless. So, meaning, connectionless, wala siyang dedicated path for the entire communication. Kaya sa sinabing connectionless. So, si circuit switch is ay merong connections. So, it could be independently treated from one another. Okay? So, when it comes to scalability, kung gusto mong mag-add ng PC, okay lang sa kanya. Okay? Kaya nga, Diba? Let's say, for example, meron ko ngayon 10 end devices. Tapos, may mga dumating na bagong empleyado, pwede mo dagdagan ng PC. Okay, sa bahay nyo, ganun din, di ba? So, 3 lang. Tapos may 2 cellphone o 5 cellphone. Okay? But, naturally, ang connections natin ay dedicated lang so 2 or 3. So, sumusobra ka na kung may 10 kayong mobile devices tapos ang connection nyo ay ganito lang. Huwag kayong magreklamo kasi masyado nang marami. Okay? Ma-shared na yung communications mo. So, babagal na talaga siya. Okay? So, kung si circuits ay pang audio, okay? Which is telephone. Si packet switch, wide variety yung pwede niyang gamiting application. Pwede siya sa voice, pwede siya sa video, pwede siya sa data transmissions. Okay? And the thing is, with packet switch, scalable siya kasi IP-based na to. Okay? So, ano ng mga advantages of using a packet switch onto the networks? Okay? One is no wasted bandwidth. Okay. So, sabi dito, not entirely true. Okay. So, totoo naman, hindi naman ma-waste yung bandwidth mo. Okay, let's say for example, ang alatin sa'yo is 100 Mbps. Yan. Okay. Most likely, kung isa ka lang na PC, talagang sayang yung 100 Mbps. Okay, hindi mo magagamit kaagad yan. Okay, pero kung napakarami nyo naman, most likely hindi waste yan. Okay, so it basically allows you to have the efficient use of the available bandwidth. Okay, so mas maganda siya. Okay, now we'll talk about multiplexing later. Okay, service. Okay, more connection of lesser quality. Okay, and now blocking of users. Okay, so sa services, dynamic siya. Okay, depending on the network conditions. Okay, so if yung connection natin fails or masyadong congested, ang packets natin mag-reroute through other alternative paths. Ganun siya katalino. Okay, so in that case, the communications ensure that the packets and messages are continuously transmitting. Okay? So, marireceive at marireceive ni end devices yun. Okay? What else? Adaptation can adapt to network condition. Sabi ko nga sa inyo, pag nag-fail yung networks mo, easily, pwede niyang i-reroute yung connectivity niya. Okay? Next, let's introduce multiplexing, pero we'll talk about this one. So, sa data communication nyo, i-discuss din yung multiplexing. Ano ba tong multiplexing? Okay, kung mapapansin mo, this is what it looks like. So, you have a switch here sa network topology niya, and you have a switch to. So, kung titingnan mo sa physical yan, ito yung rack mo. Madaming switches yan. Magkakapatong yan. Yan. Ganyan siya. Okay, so itong switch na to ay connected to a switch and this switch is connected to another switch which is connected to another devices. And this one, what will happen here is the 3 pairs of sender-receiver share the same physical link to communicate. Ito yung physical link mo. Okay, so ibig sabihin nito, para matransmit daw, ito mga to, sa isang communication line tayo to be able to transmit here. Ito, mas maganda siya kasi yung switch natin is a multiplex packets. So, i-identify niyan, okay, from a different sender, ito sabay-sabay. So, dito, prone to sa collision. Okay? Sa buffer, logs, and so on. In this case, isa-isahin niya. O, isa ito, sa akin to, tapos sa'yo. Okay. And then, ito transmit niya yan using different packets from different senders. And then, i-stream niya into a communication line. Ito yung communication path mo. And that's the time marireceive niya. Okay? So, si multiplexing, yung combined multiple signals natin are basically streams into a single channel or a single medium. Okay? Very efficient siya because you can transmit multiple signal over the same communication path simultaneously. Okay? So, mas maganda siyang gamitin kasi ma-optimize natin yung bandwidth na binigay sa atin. Okay? And we'll be able to increase the overall efficiency nung networks mo. Okay? Initially. Okay? So, marami itong type ang multiplexing. Okay? As we go along, may mga FDM, TDM, okay? CDMA, and so on. Okay? So, yan. So, ang pinaka-common is the TDM. TDM stands for Time Division Multiplexing. Okay. So, dito, kung mapapansin mo, you do have a multiple signals. Ito yan. Signal 1, 2, 3, and so on. So, sequentially, predefined siya per time slots. So, may time slot siya for communication. So, signals has a specific time slot and specific cycle. So, yung 1 over hertz. So, this one, depende sa communications mo. Let's say, for example, ang communication mo ay T1, ang communication mo ay digital telephony. Depende yan sa gamit ng time division multiplexing. Okay? What about FDM? Sa FDM or frequency division multiplexing. Okay? So, ano naman yung ginagawa dito? Okay? So, kung mapapansin mo, you do have multiple signals. Yung multiple signals niyan, it allows you to allocate each signals into a unique frequency band. Okay. So, itong signals mo, may sarili siyang frequency band. F1, another signal, may sarili siyang F2. Okay. Then, ito ay tinatransmit natin simultaneously without interfering lahat ng signal 1, 2, and 3 mo. So, may kanya-kanya siyang frequency. Okay? So, ang common examples nito, makikita natin to sa cable television, sa analog televisions, okay? Yung mga nagbo-broadcast using television broadcasting. Okay. So, kung mapansin mo, ito yan, di ba? Frequency, ito channel 7. Si channel 2, wala, di ba? So, ito si channel 5 and so on. So, yan yan. So, isang signal, isang frequency. Ito yung pinag-awayan sa Senado, itong FDM na to. Kasi daw dapat isa lang ang nilalabas ni ABS-CBN, hindi marami. Di ba si ABS-CBN maraming ginamit. Okay? Supposed to be dapat isang frequency lang ang binigay sa kanila. Kasi ang binayaran nila ay isa lang. Okay. Next is the multiplexing methods. Okay. So, there are different methods out there that pwede mong gamitin. Okay. So, in this case, yung statistical method shows us there is a divisions of communication medium into the number of channels of a variable bandwidth. So, what happens here? So, dynamic yung multiplexing technique. Okay? So, ang ginagawa niya, sinishare niya yung communication channel among multiple users based on different data streams. Okay? So, nagbabari siya. Kunwari, katulad nito. You have telepono, radio, and game console into one stream. Okay? At marireceive din niya. Okay? Unlike other type ng communication like kanina, yung TDM, naka-fix slot siya to allocate yung user regardless kung anong type ng actual data transmission siya. Okay? So, very dynamic ang communications. Okay? So, the user in a statistical transmission can transmit data at different variables. So, pwede tayong mag-adjust ng allocations niya, ng mga resources niya, para ma-accommodate natin yung number of the user para gamitin to. Okay? Very efficient siya, okay, for bandwidth allocations kasi very low yung activity ng users natin. And there are cases na yung bandwidth na yun ay hindi nagagamit. So, kung hindi nagagamit yan, pwede nating i-assign yan to other users. So yung other user na mas may higher demand, ma-optimize yung communications. Okay? Katulad ng ginagamit mo sa internet. Okay? Na statistical multiplexing. Okay? So, meron tayo ditong 500. Kunyari, sa akin ang binabato 500 megabits per second. So, yung iba, although ina-allocate natin yan, so yung iba 100 lang, iba 200. Pero just in case, yung mga hindi masyadong gumagamit ng bandwidth, pwedeng gamitin ng iba. Okay? So, paano hinahandle ngayon ni communications yan? Hinahandle niyan using, again, statistical multiplexing. So, gumagamit siya ng buffers, tapos nag-queue siya. Okay? So, what happens here is, katulad ng ginagamit nyo sa YouTube. So, temporary, nag-store tayo ng buffers before transmission. So, kung nag-store na tayo before transmission, kaya nakikita nyo, mabilis na. Kasi, kapag nakakapag-buff na tayo ng mas malaki, smooth yung panonood mo sa YouTube. Smooth yung panonood mo sa Viva Max mo. Kasi dire-diretso. Kasi nakapag-buffer na siya. And that is basically statistical multiplexing. Okay? Now, there are disadvantages of using a packet switch. Okay? So, one is no guaranteed bandwidth. Okay? So, variable delay siya eh. Okay? Yung packets natin in packet switch may take different routes, as I said, to reach the destination in different delays. Madidelay at madidelay yan. Okay? And the conjunction. Okay? So, yung variability naman, magandang impact yan when it comes to real-time applications. Katulad ng voice nyo. Yung voice nyo, bibihira yung delay. Naka-ano na nga tayo ngayon? Naka 5G na yung VIP natin. Okay? Pati yung communications natin ngayon, naka ganun technology na. Okay? In terms of the higher networks, what happens here is, siyempre, magkakaroon tayo ng loss, most probably, at magkakaroon ng delay. Okay? But, in other networking, yan talaga yung challenge natin. Okay? Which is the network congestion. Okay? Kasi, alam naman natin, kapag congested yung networks natin, may pagbagal na tayo. Okay? Ang tanong lang is, paano mo ma-manage yan? Okay? Using, sa security, gagamit ka na ng bandwidth allocation, gagamit ka ng IP filtering, gagamit ka ng MAC filtering, and so on and so forth. May mga mechanisms na para maiwasan natin yan. Pero nandiyan na yan. Okay? So, there would be a failure of packets na pwedeng mag-loss during the transmissions. Okay? So, the packet switching can be lost or corrupted also. Okay? During the times. Okay? So, that's basically the end of the chapter 1. Okay? Let us proceed now to chapter 2. Okay. So, this chapter 2 talks about the 7 layers of OSI. Let me share. Okay. Now, topic 2 talks about layering. This is more on the 7 layers of OSI. Introductions to open system internet connections, which is the 7 layers of OSI, which sabi ko nga sa inyo, kailangan nyo i-memorize by heart yung different layers of applications. Okay? So, let's talk about layering. Okay? So, yung network applications natin involves a communications of 2 or more hosts. Okay? So, we have here, mapapansin nyo, you have the host 1 and host 2. Okay? And different hosts connected through a cloud. So, it's basically 2 or more devices connected over the networks. Okay? So, these applications, okay, are designed to perform specific tasks. Okay? To be able to exchange information from one devices to another. Okay? Uh, excuse. So gagamitan natin siya ng uh, technology. Okay? And which is network applications. So the communication take place on a local environment. Okay? Pwedeng sa offices, pwedeng sa home, or in communications nyo can be over the internet. Let's say, for example, you're downloading a video, a movie, or music onto the internet, and this, basically, you're using an applications. Okay? Katulad niyan, kung magda-download ka ng movie, ng music sa Spotify, okay? So, you do have an application sa cloud, which is the Spotify. Spotify is a cloud-based apps. Okay? So, in an abstract way, you can think of this one is a series of layers. Okay. So each of the layers has a specific communication process. Okay. So yung concept na to is basically what we call an open system interconnection. Okay. So which is the open system interconnection is the model. Okay. Which is other terms is TCP/IP or Transfer Control Protocol Internet Protocols. So this concept are basically divided into different layers. Okay? So yung sinesend mo dito at nire-receive dito, we have sender and the receiver. Marami siyang pagdadaanan na layer. Very complex functions. Okay? So, dyan natin madidiscuss yung tinatawag nating 7 layers of OSI. Okay. So, common services. How many applications may share common functionality? Okay. So, many applications now share functionalities. So, developers often use to integrate different functionalities in each application. Okay. So, let's say, for example, the technology of the authentication and authorizations. Okay. So, sa authentication in authorizations, so, may mga mechanisms tayo na gagawin. Like, for example, to be able to access an application such as Facebook. Ano ba ang ginagawa ni Facebook sa'yo? Ino-authenticate ka niya. Okay. It handles authentication if you are really the user. Okay. So, you need to have the username and password. So, common services niya is it has a centralized authentication services. So, ino-authorize tayo na gamitin yung server ni Facebook para ma-access natin yung mga pictures nyo. Kasi, saan ba naka-store yung mga pictures nyo ina-upload doon? Sa server side yan. Okay? Kaya nga, ang architecture ni Facebook, isang user, at least 1 or 2 or 3 hard drives yan na terabytes. So imagine niyo gaano kalaki ang ini-invest ni Facebook. Okay? Mataas din yung investment niya sa iyo kasi free naman ang paggamit mo. Nagbabayad ka ba kay Facebook? Ha? Sino nagbabayad kay Facebook dito? Wala. Okay? So you're using the services of Facebook. Okay? Pero siyempre kumikita si Facebook. Okay? So you do have this data storage and retrieval. Okay? So, ano naman yung approach na yan? So, pwede mong mag-upload ng pictures mo, pa-upload ka ng videos mo sa TikTok, ganun din. Mag-upload ka sa YouTube, ganun din. Binabayaran ka pa, kaya ang dami YouTuber hindi na nagtatrabaho Nag-video-video na lang. Okay? So, yung functionality ng mga services na yan, ino-offer yan. Okay? You can have your own data servers, okay, which handles the retrieval. If you do have an infrastructure, you can do that. Okay? Or it could be a shared environment or shared databases, or it could be a cloud-based storage wherein multiple applications are put into the cloud and make use of that applications katulad ng server. So sabi ko sa inyo, yung you do have a Windows Server 2023 or 2022, pwede mo i-install yan sa cloud. Tapos dun ka na mag-configure ng DHCP mo, ng file server mo, and so on, sa cloud na. So pwede yan, okay? So, there are different approaches and common services na pwede natin gamitin. So this functionality needs to be integrated on each applications. Okay? Nakawa? So marami yan. Okay? Let's say for example, what else? Mga user interface components katulad ng mga buttons, mga forms, mga widgets. So yung mga yan, into a web development, okay, you need to utilize the user interface library and design a consistent and reusable components. And it makes sure that these functions are to be used across the systems. Okay? So next we have the FTP. Okay. So dito kung mapapansin mo, this is File Transfer Protocol, Video on Demand or VOD. Okay? And let's compare the two. Okay, their communication model and the advantages of using this one. Okay. So pag gumagamit tayo ng FTP para saan to? Okay. So yung FTP, it allows you to communicate via a client and the server. Okay? So ibig sabihin, yung isang PC mo could act as a client and act as a server. Okay? Saan natin mostly ginagamit to? Let's say, may website ka. Okay, nasa bahay ka. Gusto mong baguhin yung content ng website mo. So, picture. Gusto mong maglagay ng picture, lagay ng video, baguhin yung text. So, ang ginagawa mo dyan is in-FTP mo lang. Okay. So, another concern natin is, let's say, for example, nandito ka sa PC mo, nandito yung server mo. Tapos yung server mo, kunwari Cisco yan, pwede ka mag-FTP. Hindi mo yan basta-basta ma-access kasi may username at password yan. Kapag nag-FTP ka. Okay? So, that's basically a process. So, ang gagawin niya, okay, it uses a smallest number of channel abstractions. Okay? So, yung clients natin, this one, okay, the clients initiate a request, okay, to the server. Ayan yung logo na nakikita nyo. Okay? Now, kapag nag-request siya na magpa-file transfer siya. Okay? So, yung request and reply channel, this one, this is the reply channel. So, the client sends a commands, a request to the server, and the server responds dun sa request niya. Okay? At i-acknowledge niya, yung ECQ. Oy, nag-request ka. Okay, natanggap ko. Okay? Now, dito, it uses separate channel for the actual data transfer. So, sabi ko nga, kung magta-transfer ka ng video, image, ibang separate channel yon. Okay, for FTP. Okay? So, you need to establish a communications, a data connections, to handle yung reliable transfer of your data. Okay? Now, depende yan. Okay? Sa tina-transfer mo. Okay? What about the VOD? Okay, video on demand. Okay? So, video on demand naman, ang ginagamit dito, okay, same concept ni FTP. So, file transfer, server client din siya. So, yung PC mo could act as a server or act as a client, vice versa. Okay? So, pwede tayong mag-request ng video galing kay server papunta sa'yo. So, similarly, pwede ka mag-request, okay? Isi-send niya, mag-reply siya, and so on. Okay? Now, the thing here, sa video on demand, it uses a continuous message stream. So, may sarili siyang channel para ma-transfer yung video na ni-request mo. Okay? So, anong nangyayari dito, real-time yung communications mo from your server. Kaya dire-diretso yung content na napapanood mo yung video or nare-receive mo yung video. Okay? So, ano na bang pinagkaiba niya? Okay? Si FTP tsaka si Video on Demand uses a host-to-host communication. Okay? But, si FTP uses a separate data channel. Si Video on Demand uses what? A continuous message channel para ma-deliver yung requested na content mo. Okay? Despite yung pagkakaiba nito, okay, very effective siya kapag ginagamit natin sa networks. Kaya nga, until now, gumagamit pa rin tayo ng FTP to transfer. Okay? May mga clients to, may mga piece of softwares na FTP clients. Okay? And free yan. Okay? So what is simple layering? Examples. So let's create a simple using a request reply or RRP protocol. So this is the simple one. Okay? The other simple is what we call MSP or message streaming protocol, and the other one is HHP or the host-to-host protocol. Okay? So let's say, for example, we wanted to request a data between two hosts. So ito yan, host 1 and host 2. Okay? So at the bottom ng image natin, there is a fundamental communications between the two hosts. Okay? This is the basic communications niya. Okay? So, what happens here is very reliable transmission control protocols natin. So, gagamit tayo ng TCP for host-to-host communications. Okay? So, ano nang gagawin natin? Okay? So, you have on top of this one is have the HHP. So, in top of the layers natin, we have the HHP or what we call host-to-host protocol. So, yung host-to-host protocol, siya yung nag-handle ng request and reply. So, nag-request ka, i-reply niya, nag-acknowledge siya o na-receive ko yung reply mo. Okay? So, mag-i-initiate tayo ng communications. Okay? So, in other protocols, it could be an operations wherein you will send a request, you will receive the request, and you send the reply, and then you receive reply. Next is the MSP. Okay? Paano sa MSP or the message streaming protocol? So sa MSP ngayon, ang gagawin niya, it's basically above the RRP. So it focus on to the continuous streaming. Kung mapapansin mo dito sa image, video yung continuous streaming natin. Ayan. Okay? So it establishes a communication which is continuous ang stream ng data natin. Kaya nga, tinan mo, gusto mo ba yung video mo tumakbo dito sa RRP rather than MSP? So anong may itsura ng video mo? Pixel yan ang makikita mo. Ganyan-ganyan. Kung hindi mo siya lalagyan ng dedicated line. Okay. So dito papasok yung another communication ng HSP mo papuntang RRP. So the host-to-host communications tayo papuntang RRP. So it handles the reliable communication, yung HSP natin. Pero yung packets natin will use a request-reply protocol. So sa request-reply protocol, yung client natin magsisend ng request. So mag-indicate siya that the server, the user will request to the sender na specific operations. Katulad nan, file lang or digital library applications. Or kunwari, nandito yung archive. Yung archive natin ay libro or documents. Yan. Okay. Very little lang. So, anong gagawin niya? Send the request, mag-reply siya, okay, acknowledge, i-confirm niya yung communication, i-stream niya ngayon yung data mo over the communications. Okay? Kaya marireceive mo ngayon dito yung data. Kunwari, nag-request ka ng TOR mo, graduate ka na ng 20 years ago. Okay, naka-archive na yung data mo. Okay? So, ito yung gagamitin mong applications. HSP, RRP, and then this one. Okay? Next, layering abstractions. Okay? So, paano naman yung layering abstractions? So, sa layering natin, ito yung, it refers to the organization wherein each network infrastructures or functionality is very distinct. Okay? Yung layer na yun. So, yung isang layer na yun provides specific services. Hindi siya pwedeng mag-combine. So, itong services na to, ito na yung gagawin niya. Yung above sa kanya, iba rin yung gagawin niya. Okay? At i-consume niya yung nasa ilalim niyang layer. So, kung mapapansin mo sa operations niya, that is layer K minus 1 to layer K plus 1. Okay? So, yung layer K ko ngayon will have specific protocol. Okay? So, to manage yung complexity natin, naging modular siya, abstracted. So, itong layer na to, another layer, are abstracted from one another. So, wala siyang pakialam. But, it offers interoperability. Or basically, the standard communication ng each layer to another layer. Okay. Nakuha? So, ang nangyari sa kanya, each functionality ng each layers natin across to different applications na magkakaroon ng multiple application. For instance, you do have a network layers. Yung network layers natin provides a communication for specific operation. Like, networks talks about routing applications. Okay? Let's say, for example, another layer is transport. Siya naman yung layer for FTP. Yan. Okay? So, it uses the FTP or File Transfer Protocol. Okay? So, each of the layer, meron siyang each functionality onto the networks. Kaya, layer K minus 1 to K plus 1. So, etong data mo na nandito, madadagdagan na madadagdagan yan. Okay? Madadagdagan siya as it moves from layer 1 to layer 2 to layer 3 up to the layer 7. So, mababago na yung laman niya. Okay? Which is needed during the transmissions. Okay? So, looking into the layers a bit closer. Okay? Now, yung service interface natin with upper or lower layer. So, the service natin, so let's say you, the service interface natin with upper and lower layer. Okay? Itong layer na to, it basically defines how the higher layer can request services from the lower layer. So, pababa. Okay. So, for example, sa service interface, pwede natin gamitin dyan yung transport layer. So, sa transport layer, nag-request tayo ng reliable data transmission from the network layer. Okay? From upper to lower yan. Okay? What about a lower layer? Okay? Si lower layer, pabaliktad naman. So, kinukonsume natin yung services from that layer directly below. Okay? So, ano yon? Kung dito, ang example nito ay transport. Okay? This one, the lower layer is basically a common example would be a network layer. Okay? So, anong ginagawa niya? It basically relies on the services of the data link below yung data link for reliable communications. If so, okay? Nakuha? So each of the layer enables communication, okay, within each layer and each peer-to-peer communications. Ito yun. This is what we call peer-to-peer interface. So between the different layers natin onto different hosts. Meaning, one host can, okay, with the same layer on another layer. So it basically provides an end-to-end communication from one another. So this is a host 1 and this is the host 2. Okay? So, ini-ensure natin that there is a real communication between two interfaces. Okay? Next, we do have what we call the hierarchical layer structures. Okay? So sa hierarchical layers, we do have this one. Layer 1, 2, 3, 4, and 5. Okay? So, ang tinatawag natin yung hierarchical, this is a different layers in a structured format. So, each of the layer has specific responsibilities. Okay? And each responsibilities provide services to each layer above and layer below. Okay? Para ma-improve natin yung overall network systems natin, okay, there are several layers that we need to take considerations. Okay? So, in hierarchical, kaya sa sinabing hierarchical, ang approach niya is basically top to down fashion. Okay? So, each layer provides functionality pataas at pababa. Okay? Well-defined yung communications niya. Okay? So, dito kung mapansin mo, layer 1 and 2 interface, layer 2 and 3 interface, and so on. Okay? So, sa open system interconnection, the TCP model are the most common example of hierarchical, okay, which is the open system interconnection and the TCP/IP. Sa ibang libro, ang TCP/IP is what we call internet models. Okay. So let's talk about encapsulation. Okay. Okay, sige. I think dyan na muna tayo. Natatapos. Okay. So we'll continue next meeting. Yung other remaining natin na time will be posted. Okay. Hanap po namin yung schedule na available. Okay. So we'll continue the lectures about the OSI model. So papasok na tayo sa discussion ng open system interconnections kung how each layers communicates from one layer to another. Okay. To give you a glimpse, kung bibigyan mo siya ng analogy para siyang snail mail. Okay. Yung snail mail para siyang sulat. Okay. Kung paano yung sulat nag-ooperate. Parang ganun yung concept. Okay. So paano ba yung nagsusulat? Kung gawa ka ng letter, tapos may sender tsaka receiver, so saan pupunta yung letter mo? Sa common postal system, yung plain old postal systems natin, parang ganun yung operations ni open system interconnections. Okay? So siguro dyan naman na tayo mag-end. That's already 7:30 plus. Okay? So any questions? I will entertain questions muna before the time ends. May question ba kayo, guys? Wala naman.
Bravo, sir.
Okay. Yung mga late enrolling, mag-email sa akin yan kung hindi pa kayo naka-add sa Brightspace. Okay. So I could add you sa Brightspace. Okay?
Sir, pwede po mag-ask po regard iba sa ano po, another subject nyo po,
Ay,
doon po sa
doon na lang
Microsoft.
sa another subject. Hindi ako. Okay?
Sige po. Sige
Ah,
po.
sige. Wala
Thank
na.
you po.
Okay, sige. That's all. Maraming salamat at magandang gabi. Hindi na ako mag-check ng attendance kasi automatic naman to. Okay? So maraming salamat at magandang gabi sa inyong lahat.
Thank you po, sir.
Thank you po.
Thank you, sir.
Thank you, sir.